I see attendance yet dwindles. It's, you know, I know I'm doing it to myself by doing the online thing as well, but I still like to see butts in the seats, you know? But anyway. So, I don't believe there are any outstanding announcements. The test isn't this weekend, right? It's next weekend?
As far as I remember.
Yeah, right. So we'll worry about the test next week then. So, good. Excellent. So, last time in class, we had finished off the birthday calendar example, and we were just about to move on to the mean calculator. This is the calculator which calculates the mean of a group of numbers. It is not a calculator that insults you. It's like 4 plus 4 is 8, dummy. That's not what we mean by mean calculator. Terrible joke, I know. I tell it every semester. So, this class that we are about to write to calculate the mean of a group of numbers should have two methods. Number one, we need some way to add numbers to the data set. And number two, we need some means of calling the mean out of that set of numbers. The mean should account for the same number being added multiple times, obviously. So, before we actually implement this as a class, we need to make one very important decision about how this class will be structured. Anybody know what that decision is? How we structure the data. Very good, thank you. So how would we structure the data in this case? What's one way that we could keep track of all of these things we're adding? Yeah. Say that again? A tuple. Yep, we can do a tuple. However, given that the entire operation of this calculator focuses around us being able to add a bunch of numbers to an already existing data structure, I would argue that it makes more sense to use a list, because a list is mutable, and you know, you don't have to destroy and recreate the tuple each time you add a new number to it, right? But you know, to a certain extent, list and tuple is potato potato, at least from a overall standpoint. Okay, so this should be fairly easy, right? Let us define a new class. It's like, but we're already in class. It's like, not that kind of class. Class, mean calc, inherits nothing because its parents were poor. Terrible jokes. I'll be here all week. And then another week after that. Anyway, so, def, init, takes self. We'll do stuff there. We also want to fill in our methods just so that we have them there. Def, add, self, and m. Def, mean, takes just self. Right? So we want to use a list. Self.values is equal to an empty list. When we add something to the list, very simple. Self.values dot append n. And calculating the mean, also very simple. Return sum of self.values divided by the length of self.values. Help if I can type. There we go. Is anything more needful? Should this about do it? Yeah. Cool. So let's just say we have capital C is a mean calculator. C dot add 1, C dot add 3, C dot add 4, C dot add 10, C dot mean, home, print, and if you're not already using the home and end keys on your keyboard for programming, I highly, highly recommend them. Like it might take a bit of an adjustment at first, but once you get into the habit of it, it'll drastically improve your typing speed. Especially with coding, because you have to jump to the beginning and the end of lines a lot. So, yeah. Anyway. Yeah, always keep in mind that your keyboard was designed for programming first, and then a decade later for word processing, right? So, good. So let's run this thing. We get nothing. Why? Did I save it? I did not. There we go. 4.5, which I'm sure if somebody verified with the calculator, that would be great.
Nick, could you get the lights?
Oh, yeah. I don't know if I can get any more lights than that. That's like,
okay.
That's as much as I can go without complete darkness. So, I think that's, yeah, it does seem like the projector is a bit more faint.
Yeah, it does.
Any objection to having the lights out completely? Okay, if it makes the board more visible. All right.
Nice.
There we go. Cool. Better?
Yeah.
Awesome. Also makes my cool lightsaber show up more.
Oh, true.
Yep, there we go. Anyway, so far so bland, right? This is not a particularly interesting example. So, there you go. Very, we did directly what was on the next slide. So, here's the thing though, right? Our minds immediately cast themselves into the idea, okay, sure, but what if we did this more efficiently, right? What's the single point of inefficiency in this class as it's currently sitting? It's not runtime complexity. Yeah?
Is it that you have to like individually add all the numbers?
Yeah. Like we're keeping all of the values in a list. This consumes memory. In the end, we only need the sum and the number of elements. It's actually possible to keep a running tally of how many elements we've added so far and their running sum. We don't actually have to hold all these values. So let's make a new version. Mean calc 2. Self dot sum is equal to 0. Self dot count is equal to 0. So rather than appending to some data structure, self dot sum plus equals n self dot count plus equals 1. That's a Sesame Street reference. Then return self dot sum divided by self dot count. Save her up, and you can see. That would, let me just do that there. Boom, there we go. We can see that we get 4.5 out of this newly formulated version that holds a fraction of the memory for large inputs, right? it works exactly the same. So let me ask you guys a question. From the perspective of someone who was using these classes rather than developing them, is there any difference whatsoever in their use of either mean calc or mean calc 2? Could they distinguish the two if they had to? Yes. No. The means by which the data is stored is abstract from the perspective of the program. A person using this mean calc function, this mean calc class, it doesn't matter if it's stored in a list or it's stored in a couple of integers. It seems the same way from the outside, right? And this is intentional. You should not have to worry about how things are being stored underneath the hood. That's the whole point of abstraction and modularization. I would add one thing to that, however. What's the disadvantage of using this formulation? Anybody got any ideas? You?
I've seen your adding more functions. For example, somebody put in a wrong number, they want to remove it. Maybe we should not have this system with adding.
Absolutely. Anybody else got any ideas? Thought I heard some. Yes?
I couldn't totally hear what you were saying, so I might say the same thing, but when you have a list and you have to keep track of what's been put there.
Yes. So, what both of you are kind of getting at here, with this formulation, you have to assume that each number that's gone in is correct, right? Because you don't have a history of the numbers which have been added. So, you know, while you're buying a whole lot of memory, you're doing it at the expense of being able to review the data that has been put in. Another thing that this defeats is the ability to add more functionality, right? One function that is commonly grouped in kind of like these very basic statistical packages is mode and median, right? Both median and mode require you to be able to actually look through all of the data elements, right? And order them. So if you wanted to expand this eventually in that direction, this is not going to help you. This is the one that you would build off of. In fact, if you wanted to build a class that could tell you median and mode efficiently, what you'd do is you would set this guy up such that the add function kept this list sorted. Finding the correct place in a list for an element in order to keep it sorted is actually a big O-N operation because it's essentially linear search. Well, actually, sorry, it's binary search. You can do that with binary search. So that would be big O log N, where log is base 2. So that's pretty efficient. But if you want to order a list, you know, if you want to order a list when you need that list ordered, you're going to pay a price for it. So by changing the add function from a constant time algorithm that's written big O1, by changing it from a constant time algorithm to a logarithmic algorithm, you maintain a sortedness property inside of this class because that is useful, right? You know, assuming you don't need like some kind of history for them in terms of the order they were added, because you'll lose that if you sort it. But it's also possible to maintain that while you just keep a secondary array of placements, and then it's fine. But anyway, if a property like sortedness is required of a data structure, it makes a lot of sense to make sure that that property is maintained in that data structure by the methods of the class, right? Any questions about that? Yeah, good. Like this is like efficient algorithm design, right? It's like if you're going to rely on a property like sortedness, that property should be present without you having to do anything else, right? But anyway, good. So, yep. So, I've talked about abstraction a lot during this lecture. I will read this slide. Functions provide functional or algorithmic abstraction. Functions can be used without needing to know the algorithm they implement. The documentation specifies declaratively what the function computes. Classes provide data abstraction. Classes can be used without needing to know the data structures of the implementation. The documentation refers to abstract data structures that may not be present in the implementation. So, yeah, basically. Although I would say it's kind of it's a bit of a Richard relocation to put things in your documentation that don't actually, that aren't actually implemented. Like if you say, I have used lists for all of this, and then you actually didn't, that's just, you're just screwing over the next person who has to try to modify your class. Anyway. So, data abstraction of classes assumes that the attributes are not manipulated from outside the class, something particularly difficult in Python, as it turns out. Nothing actually prevents outside functions from accessing and modifying the contents of member variables unless you do something specific. To prevent it, this can lead to an inconsistent state. If, however, you prefix a member by a double underscore, that member will be private. So now we have to talk about the difference between public and private. Python will prevent any code outside this class from accessing private members. So, I want you to think about your standard fast food restaurant, right? And when I say restaurant, I mean the physical building itself, right? There is an area of that restaurant which is public, and an area of that restaurant which is private, right? Everything on your side of the counter, that's all public, right? Public washrooms, public tables. Anybody can come in, walk into this restaurant, order a cheeseburger, sit down at the table, eat that cheeseburger, throw their wrapper away in a public waste receptacle, etc., etc., etc. And in fact, the ordering of food itself is a public function as well, because the public person can do it. Private, in this metaphor, would mean the employee-only areas of the restaurant, right? The kitchen, employees only. The supply cupboard, employees only. The manager's office, assuming they have one, employees only. Many of the vital functions of that restaurant are in employee-only areas, and it wouldn't be a restaurant if not for that fact, right? The burgers are made in the kitchen. They are consumed in the public area. This is roughly speaking the type of conceptualization that you should have when discussing public versus private members of classes. So I just want to take a brief moment to say how stupid this is, that they use double underscores here in Python. This is so annoying. Every proper programming language, right? You declare it, whether it's public or private, with the typing information, and it just remembers that, and you don't have to do anything else. In Python, you actually have to include this double underscore every single time you use the variable, because it's part of the variable's bleeding name for no particular reason except to annoy me. Yes?
So is that why the initializer typically have one double underscore before and after?
Sort of, yeah, it's, except that those are actually publicly accessible, so it's not even consistent with its own damn conventions. But if you have two underscores on either side of something, that denotes like, I believe they call them magic methods, but all that means is that they're defined in the prelude so that you're overwriting something that's already there but has some default functionality, right? But yeah, no, just in front means it's private, not public, which means that everything is public by default, right? Which kind of defeats the entire purpose of having a distinction between private and public. Because like, if you don't know what you're doing, you're going to just make everything public, which means you'll have very insecure code. So, why do we care so much? Oh,
You can't even rely on it. It's just by convention. So
Sorry?
even the private functions are just by convention. So you could still access them outside if you really wanted to. It's like it's not even a security feature. Yeah. Yeah. Exactly.
you're kidding me.
No.
You can break into Python's private members.
Yeah.
Do you just have
There's
to
no
know the
implementation of private. It's just done in like IDs and stuff to make it like, yeah.
I wonder why nothing's written in Python. That's so weird.
I know.
You know what it bloody is? I don't know, but there's like some kind of conspiracy. It's like Python. Nobody used it until like 10 years ago, when suddenly, like all of the intro programming courses started teaching Python.
Yeah.
And then Python's popularity goes up. Surprise, surprise. And then it's like, oh, now everybody's doing everything in Python. It's like, yes, but you would be better off doing it in literally anything else.
Yeah. It's good for scripting, bad for literally everything.
If you need to hack something together in like very little time,
Yeah.
and you don't have high performance requirements, and you're not like
And
like
it's
I
small.
personally, like I use Python personally to like hack together little scripts to convert CSV files when I'm doing upgrade uploads to Mosaic and stuff like that. But if you're doing a serious project, you should use a serious programming language, and Python is not a serious programming language. I'm sorry, but it's true. So anyway, I'm going to talk about a distinction because it's important to object-oriented programming, despite the fact that the language we're studying doesn't even implement it properly or possibly at all. Anyway, so I'll talk about C++ then instead. So when you declare something private, it is accessible to the class in which it is located and to nothing else. Right? Private means that just employees can access it, right? Public, on the other hand, means that anything which instantiates the class can also access that method. Now, you may be thinking to yourself, this makes a certain degree of sense for data, right? But why methods? Why would you even need a private method? Well, the reason that you might make some methods private is because you need a function, right? Like, we go back to the old functional abstraction, the reason we've been writing all these functions so far. It's useful to declare functions, right? But you don't always want those functions polluting your global namespace, right? You want, perhaps, those functions to be associated with that class to which they are useful, and when they're not useful to anything else. Which, you know, normally means that they operate specifically on the data that's in the class or something like that. So yeah. It's the principle of least privilege. I've talked about the principle of least privilege before, right? Yeah, a little bit. Just a reminder. It is inadvisable in any part of life. I think this is a thing that actually generalizes pretty easily to life advice. It is foolish to give anyone or anything more access than it requires to perform the task it needs to perform, right? If you're having a plumber come over to fix your drain, you don't give them their house key on the way out, right? You don't give them your house key when they leave, right? You maintain restricted access, right? So private members restrict access to parts of the class. So, for example, with our mean calculator class, one of the things that we may wish to do is we may wish to prevent the exterior or public user from modifying the data in that that's being stored in the class without going through one of our access methods, right? It's a good idea to write methods that allow the user a specific way of accessing your data. You enforce that by making the data private, so that's the only way they can get at it, right? So, it's reasonably simple. You prefix double underscore anytime self.values appears. One point, there we go. And now, if we switch this back here, there we go. And we say print c.values with a double underscore. Oh. Another stupid thing about Python is that they'll only tell you one syntax error at a time. So, when I try to print c.__values, it tells me attribute error. Mean calc object has no attribute ___ values, which is a dirty lie. It does. It's just pretending not to. It's like it's got an elephant behind it, and someone's asking him, "Hey, what's with that elephant?" He's like, "I don't see an elephant." Elephant? What are you talking about? There's no elephant in this room. So, anyway, this is the same example, but using the mean calc 2. So, classes. We see before us a diorama of video game objects and characters. A diorama which severely dates this set of lecture slides. So, what objects do you see? What inside of this video game environment might be an object? Yes?
I'm assuming that all of the players are under some player object.
Players in some player object class. Yes. Yes. Coins, collectibles. Yes. NPCs. Yes. We might call them enemies. Yes. Sometimes Mario games have NPCs that are not enemies. That's a more recent phenomenon. Anybody else? Yes.
The bricks are probably under like a non-moving object or something.
Yes. Blocks would be objects. You would have block object, which is inherited by brick block, whatever you call that, question block, etc., etc. Right? Pipes. Ground. That cloud. the background gradient, that little flower, right? Everything is hierarchically arranged as a series of classes. This is especially true if you consider each one of the objects which is being rendered in this view of the game it has its own three-dimensional model, which is composed of all of those tiny little triangles that I was talking about previously, although they might do stuff to smooth it out. Also, with pre-rendered stuff like this, because it's pre-rendered, they can vastly increase the number of triangles which they render, because it's much easier to, like, you can spend all of the computer time up front to pre-render it. You can't make it render that fast if it's just gameplay. Although you don't typically have a problem with that with Nintendo games because they're so freaking easy. You know. Anyway, so that's why you should never trust E3 trailers. Anyway, so if you wanted to create a set of data structures for representing the initial state of a Super Mario level, what classes would you create? Which ones would be subclasses of the other? What properties and methods would those classes have? So let's think about some methods now. Pardon me. What sort of methods would Green Mario have? Yes.
Move, jump, collide, or like
Move,
big.
jump, collide. Yes. Anybody else? Yes.
Get coin.
Get coin. Take damage. Stomp Goomba. All of those nice things. Here's a question. Is Yoshi a character or a power-up?
Probably power up. When you get hit,
Subject
when you
matter
get
note.
hit, you lose it, right?
Yeah. So he would be like one of these guys until such time as Mario acquires Yoshi, right? At which point, Yoshi the object is destroyed. Yoshi the power-up is created in the same instant. So you see a seamless transition, but you've actually killed Yoshi by jumping on him. Yes?
What is Yoshi?
Oh, he's the little dinosaur that Mario is riding on.
Okay.
Yeah, it does certain things like make your jump a bit longer. It allows you to take one extra hit from enemies, that kind of thing. You know, standard video game power-up type stuff. You can, like, eat fruits and occasionally get one-ups. Anyway.
And you cannot do it without.
Can you what?
Mario cannot do it without Yoshi.
No, he's Mario is perfectly capable of self-propulsion in the absence of Yoshi. Otherwise, he would have no means of collecting Yoshi. Yeah. Anyway. So, how about a block? What sort of methods would a block have? Aside from the collision, right? Which is a physics engine, which is a whole other thing.
Don't they have invisible blocks?
They do have an invisible
Whether
block.
it's visible or not?
Yeah, so visible, invisible would be a state, right? And then you would have a method that would, like, if you collide with an invisible block, if it's the type that becomes visible once you collide with it, the collide method would then flip the visibility property of the block, right? If we have a question block, one of the things that you have to know about if you're a question block is what power-up do you contain, right? Or do you contain a coin? Or do you contain nothing because you're stingy? Getting hit is a method, right? Here's a little bit more advanced video game stuff. How does the question block know whether it's being hit from the bottom or the top? Because they only work if you hit them from the bottom, right? Yes, sir.
I mean, I don't know how Mario is programmed, but I guess one way to do it would be to like physically detect what like barrier you're colliding with. Like if you use like a line colliding method for like a character box, you know.
Mm-hmm. Yep. So that would be one way. So inside of this object, invisibly, you would have a collider here, right? A special collider surface that would generate the method trigger, right? That's one way of doing it. Another way that might actually be easier because it doesn't involve as much work from the physics engine. Whenever Mario touches it,
Check below.
check the position of the block relative to Mario. If
Mhm.
Mario is above, then no hit. If below, then hit. Right? Probably the same way that it worked on Goomba. Like, if you think about Mario as a Nintendo Entertainment System game, that would be how they would do it, because they didn't really have a physics engine the way we think of physics engines these days, right? Question?
So you mentioned Yoshi as an object compared to a power earlier. I was wondering if that would be the same for mushrooms, how Mario starts off as small and then comes in contact with the mushroom, and that's like an object at first and then power up. So nothing's actually changing, it's just all being destroyed and it's created the same instant.
Okay. In detail, this would be, and again, I don't know specifically because I don't work at Nintendo, but this is if I were programming it, this is how I would do it. So, first event that you need, of course, is for this question block to create the mushroom, right? So, Mario hits block event. That causes animation whereby mushroom rises from block, right? After it has risen, or possibly during its rising, before it enters its free movement state, it is created, right? It is it depends on how you want to do it. If you do it as an animation on the block, then it doesn't get created until it hits the free movement stage. But at any rate, when Mario makes contact with the mushroom from any direction, that game object would be destroyed. Mario would then be triggered to have the grow from Tiny Mario to Super Mario animation, right? And then it would attain that state. Like the Super Mario state would be something I would put in the Mario object, not in the mushroom object. That would be too much information to be contained in a thing that you would be creating and destroying like that, right? Like, Mario is the player. The player, at least one player, will always be present, so it makes sense to group player-related actions in the player himself, right? Make sense? Any other questions? Yes?
This is what Yoshi did. So he becomes a method,
He becomes a which, sir?
a method, if he's going from object to method.
Yeah. So, in the same way that I would put the difference between Mario and Super Mario, I would encode that in the player character class, right? Yoshi, as he's thusly configured, would also just be one more state of Mario, right? So yeah, when Mario acquires Yoshi, a little animation plays, right? And then you are in a state where Mario and Yoshi act as one body, right? It's also possible to exit the Yoshi state at any point by pressing the special jump button. At that point, the Yoshi object, the Yoshi character object, would be reinstantiated at the point of the jump off, right? Which is why at that point Yoshi has Yoshi's own independent physics and can fall down and hit. Yes?
You said that when they join, do they join and become a new object itself, or are they just two objects working together?
The way I would do it, all you would do is modify variables and place some animations within the Mario object. Yoshi himself would be destroyed.
Okay, so it becomes a completely new object. Okay.
No, it's the same object. It's in the same way that Fire Flower Mario and Super Mario would be the same Mario with different textures.
Oh, okay.
Right? This would be the same Mario, but with an additional model that's being modeled there. Right? Make sense? Any other questions? So that's how video games work. Good. So, possible class hierarchy for a Mario. The level itself would contain a lot of things, the locations and placements of blocks, etc. Characters could be playable or non-playable. Non-playable would include such things as Goombas and Koopa Troopas. The widget is a way that you could refer to it, sure. Blocks and pipes, bricks, question mark blocks, invisible blocks, the note jump blocks, all of these blocks would be blocks. Good. Possible properties and methods. So, playable character would have several properties. Name is big, which I would say, you know, state, you know, Mario's power-up state. Has feather. See, I would put those in one, but anyway. Number of coins acquired. X and Y positions in the game space. Not only X and Y positions, but also X and Y momentum. Mario was one of the first platforming games to have momentum as a physical feature of it, which is why Super Mario Brothers was very popular at the time, because you know, it turns out momentum is actually kind of fun. So move to X, Y. I mean, that's not how Mario would move, but how Mario moves is you read joystick position, right? And if basically you add to his momentum with a certain amount, depending on how depressed the joystick is in one direction. But anyway, like you don't modify position directly when you're programming a video game, because if you modify position directly, basically you'll end up with a problem where you like clip through solid objects and then they bounce you back out, as opposed to giving them force and momentum and allowing the physics engine to do its frickin' job. Allow the physics engine to do its frickin' job. Anyway, collect coin, draw on screen. Question mark block might have, well, it certainly has a position in space. It would have a contents. It would know whether or not it was used. It would have a smash method. It would draw on screen. That's actually a really, really important one. All of these objects would not be rendered unless something was rendering them. Make sense? Good. All right, that's classes. Any questions about classes before we move swiftly on to files? No? Okay. Nope. Good. So, okay. So, and now for something completely different. We're going to talk about files. You may have noticed that the ability to hold on to files and modify them is what you might consider a fairly major function of any computer which you may care to use. Another way of describing this is permanent memory interaction. The way that your hard disk is organized, and any of you who've used a computer will know this, you have a hierarchical directory structure where certain regions of memory are called, given certain file names and given, you know, read or write permissions, executable permissions, all of these types of systems. So, pardon me. So, just to bring it back to the Mario level, the Mario level itself and all of the structures therein, these would all be stored in RAM, random access memory, impermanent memory. When the system is turned off, such memory evaporates. What we're talking about here would be the saved state of your game progress as stored on your device until the next time you turn it on. You know when in video games where you get the little spinning wheel, it's like do not turn off power, saving. The reason that you don't turn off the power while it's saving is that you might save only half of the file because it's in the process of saving the file. And if you save only half of the file, and particularly if it overwrites the previous save file, most video game files don't do this anymore. They, keep 2 copies so that you don't overwrite the old one and thus make everybody lose all of their progress because they turned the game off too quickly. But anyway, so the data itself would be stored in a file so that it's kept through power cycle. Question?
Are related to classes or anything like that?
The means by which we will access files requires us to know about classes, but files themselves are not classes. And you can store the data in a file in a class. There are certain file formats which are meant for storing class data, as we're going to see, but files themselves are not classes. You should think of it as plain text files. You know these files that I keep programming in? You know, these guys? This is the data that we're going to be working with, right? Good. So, I am not going to patronize all of you by explaining to you what print does, but I will talk about system standard input and output. This is kind of Linuxy, but we'll get there. So, have you ever wondered how the print function actually prints stuff out to a terminal? All of this code, all of this stuff, right? Inside of the computer, there are some special files which everything knows where they are, right? If you write into these files, other programs know to look there for the information that has been written there, and they know to display it if they're the active program, right? So one of these files is called standard output. What you see in terminal is just a printing out of everything that has entered standard output, right? This is actually standard output and standard error. There are 2 of them. Standard error is just used for error messages by programs. Standard output is used by everyone. Have you ever wondered how your keyboard communicates with your programs? When you push buttons on your keyboard, those keystrokes are logged into a file called standard input. Standard input is periodically read by programs which might want that input, right? In the context of an operating system, it gets kind of tricky, but if you think about it in terms of just a terminal, it becomes the most clear. When you use Python's input method, what it does is it waits for the standard input file to fill up with characters until the last character in that file is an enter character. At that point, it triggers it to scoop up as far as the enter into a variable, store that in Python. That's how input actually works. And those keystrokes are logged to standard input automatically. It turns out that you can actually redirect stuff using, and this is definitely Linuxy stuff, and I know we haven't much time, but you can actually, in a command prompt, one of the things that you can do, which is kind of cool, is you can take the output of one program, right? Take the standard output of one program, redirect it as the standard input of another program. You can have commands use the outputs of other commands as the inputs to those other commands, right? This is known as pipeline, right? So let's see here. Find in current directory everything with a name .py. There we go. All of the elements, all of the files in this directory .py. Take that, pipeline it to Nano. No. Let's try Less.
Yeah.
So Less is a viewer, right? It's a different way of showing it. But if I go up a few directories and do the same thing, you'll see I get a lot more files and I can scroll through them easily using the Less program, right? This is because I know how to redirect the standard output of one program into the standard input of another, right? Which is hypothetically something that you should learn in Computer Science 1x C3. So, that's all I have for today. We shall resume our talk about files next time in class.